HingeTheorem, this is going to kind of be the end of this section of our test, our unit on triangle properties. And this is the end of our triangle foldable that we're creating. The next week, we're going to jump into segments of a triangle, and we're going to be constructing them. So starting, and I won't be in class on Monday and Tuesday of next week because I'm in an all-day meeting downstairs in the first floor for 2 days. So you'll have a little bit of a cumulative review that you guys are going to work on next Tuesday. But starting Wednesday, Thursday, Friday, we're going to go on to segments in a triangle, and you'll need a compass for that. So if you have your own compass, we'll bring those back towards the end of next week. But let's go ahead and finish up this portion, or this foldable here. And I ask you to copy this on the very back page, and it's called the hinge theorem. Last class, if you remember, okay, we drew triangles where they shared a side. You remember that? So like, I don't know, just kind of making something up, okay? Where this side was the longest. We looked at ordering the sides. Do you guys remember this kind of picture where they shared a side? And so we looked at two triangles that were connected. Today, we're really going to be looking at two triangles. Two triangles, and we're going to start off by looking at them not so connected. Okay? So we have a situation here where we have two triangles, and we have some congruent measures. We know that this side AB is congruent to this side YX. They have the same length. And then we also know that AC and XZ have the same length. What we do know here also is that the two angles are not congruent. One angle, angle A in this case, is larger than angle X. If that's the case, then we know that the angle opposite the larger angle, which in this case is segment BC, is going to be longer than the side across from the smaller angle. That kind of makes sense, doesn't it? So if you're opening it up and it's wider, it's a bigger angle, even no matter if the sides are congruent, then this is going to be bigger than the other one. And that kind of makes sense. I thought this picture at the bottom here was a really good example. If we have two exact same kind of scissors, okay, then don't we agree that these two scissors, the blades of the scissors are the same length? They're congruent to each other, aren't they? But if I open one pair of scissors wider than the other, doesn't the distance between the tips of the scissors, isn't it going to be different? So even though the blades are the same, which pair has the longer distance between the tips? The first one or the second one? The second one, because it has a bigger angle. Wouldn't you agree? Okay, so that's really what we're looking at. It's a little bit more complicated when you have two triangles kind of put together, but we'll look at some scenarios like that. But let's start kind of basic. So here is, I'm going to turn the lights off. These things are hard to see. At least they are for me with the lights on. So let's look. So if we look here, it says which of the following statements must be true. So I want you to look through all the possible choices. Notice what we have. We have some congruent segments, and we have what we call an included angle. So we can see that this segment SA is congruent to segment OY. We can also see that segment AK is congruent to segment OU. And then we also have the angle here on the inside that's included. Okay? Notice the angles are different. One's 70 degrees and what's the other one? 90, okay? So they're not congruent triangles. So we have a situation where we can look at this third side and make a decision about it. One is going to be longer than the other, okay? So what do we know about SK and YU? What do you think? What do we know? What do we know to be true? Which one's longer? SK is longer because it's across from the 90, correct? Okay, so isn't this the correct statement that must be true? Let's go through the other ones. How about AS and YU? Do I know anything about those two? They don't really correspond to each other. I don't know that for a fact. How about SK and YU? Do I know anything? Well, I definitely know that it's not less than, right? And then AK and YU, I don't know that they're congruent either. The only thing I know for certain is this statement to be true. Okay? Pretty basic. Now, the converse, do you know what converse means again? What's converse mean? Back to logic for a second. At least switch them around, right? The conversation, Amira, right? People twist my words sometimes. Okay? So let's go back to what the other one said. The first one. It said if one angle is bigger than the other, then one side is bigger than the other. So what's the converse going to say? If one side is bigger than the other, then one angle is bigger. So we're just going to switch them around. Okay? So let's make sure that's what it says. So if one side is bigger than the other, then the angle across from it is bigger than the other. That kind of makes sense, don't you think? Not too much of a leap there. All right, so here is where I have a situation I want you to copy into your notes. Okay? So we're going to title this the Hinge Theorem. And I want you to put today's date on it. Today is, in fact, November 14th. Okay, Hinge Theorem. And this is a situation where they're kind of put together. Okay? So it looks a little bit like the picture we did last class, but we're not ordering the sides. We're looking really to figure out what x could be. Right? So what I'd like to do is I'd like to, first of all, why don't you copy this problem down, and then we'll go through. All right, so we'll start there. Copy the problem. So if we look at this situation, we have to decide whether or not we can even use the Hinge theorem here. Okay? So what has to be true in order to use the Hinge theorem? We have to have some congruent sides, right? So do we have that? Let's look. So I see that RU is congruent to UT. So I have a pair of congruent sides. Now, in each triangle, I need another pair of congruent sides. Do I have that? You see it? They share a side, don't they? And that's going to come up over and over and over again in this class. Anytime that in a figure, when two triangles share a side, we call that the reflexive property. Any side is congruent to itself. Okay? So we could say that US is congruent to US. So yes, it's congruent to itself. I agree. So we do have two sets of congruent sides. Now we can look at their included angles. And their included angles are 60 and 5x minus 20. Okay? So what we want to do is look at the sides they're across from. Which one looks bigger? The 60 or the 5x minus 20? The 60 is bigger. Why? This is across from the 15. And 15 is bigger than 10. Would you agree with that? So let's write an inequality about that. Okay? Let's say that 60 must be greater than 5x minus 20. Okay? Do we agree with that statement? We know that to be true. One angle is bigger than the other. Okay. So let's just solve it algebraically. Let's see if we remember solving inequalities. What would I do? Add 20. Good. And then divide by 5. What's the thing you have to kind of remember with inequalities when you divide? Do you remember? Andrea? Go ahead.
If you would divide by instead of subtract,
A negative. We use it with direction. Very good. We don't have a negative here, but just kind of as a reminder, that would happen. All right, so we're going to divide by 5. Now, I kind of have written it backwards, so we might rewrite the inequality in a minute. But what is 80 divided by 5? 16. I agree. Is it okay if I rewrite it this way? So the same thing, right? I'll give it a bigger number or whatever, but it's facing towards the 16, it's facing towards the 16. All right. So I know that x has to be less than 16. Notice what the question's asking. The question is saying, what are all possible values for x? So I have an upper range. I know it's got to be less than 16. Does it have to be bigger than something? Yes. Okay, there are two ranges. There's a range of values. Josh, put your head up for me, honey. Just fill in your notes. You're going to have your notes out. Come on. Get a football game tonight. You want to get your work done first. So that's the first step. Okay? The second step is going to be to find the other end. Okay? It's less than 16 has got to be bigger than something. X can't be negative. X can't be, you can't have a negative degree, right?
It can be bigger than bigger than 5.
Okay. Well, let's see. Be careful just a second. What I do know is that the angle with X in it, this angle here, has to be bigger than 0. Would you agree with that? X has got to be, this angle has to be bigger than 0. I don't know how much bigger than 0, but it at least has to be a positive degree measure. By doing that alone, that will give you the other end of the range. Okay? So let's just solve this. We'll add 20. We'll divide by 5. And X is going to be bigger than 4. So we're going to kind of put them together. Okay? We know it's bigger than 4. We know it's less than 16. So the actual value, we can kind of write it like we did before. X is in between 4 and 16. And that's how we write it. Remember how we did that? We did that for homework, right? It has to be between what two numbers? So it's a little bit of an extension. You're taking kind of the idea of what can make a triangle, and you're looking at this theorem, this hinge theorem, and deciding whether it can work or not. Two-step process. Feel okay about it? Any questions about it? It's not that bad. All right, so if you would, go ahead and open up your packets for me, and I want us to look at some problems, okay? I'd like us to look at some of the hinge problems, so I'd like you to go ahead and open it to, you can skip the next page, because that's going to be your homework, by the way. Page 4, it says 4 at the bottom, where it says, can a triangle have this page right here? This is going to be part of your homework. So if you want to just label it homework right now, you can, okay? I'm sorry. You can label that homework. We're going to skip that page, okay? And then this is also going to be, sorry, this is also homework. So if you turn it over to the next page, you should see the top, okay? 7, 8, and 9 are homework. But this is where I want us to start, okay? I want us to look at number 10. So this is, basically, we're going to do this whole thing anyway, but I want us to look at these two problems, 10 and 11. Okay, this is the hinge theorem, and then we'll look at the ones underneath that. That's where we're going to kind of start right now. Okay? So go ahead and look at questions 10 and 11. See if we can do what we just did. Let's practice doing that. Can you write a range for the values here? Okay, what can X, or what can the values of the things be? Let's try. Make sure I'm recording this part. 10 and 11 doesn't have an X. I just mean like write AC is bigger than XZ or AC is less than XZ. Just use the AC and XZ and just write a greater than or less than symbol in between them. For 10 and 11. It's 12 and 13 where you have to write the equations or the inequalities. Okay? We have to solve for X. So what do you think about AC and XZ? What are we're going to write? Is AC bigger than XZ or is AC smaller than XZ? It's smaller, because 75 is smaller than 101. So we're going to say that XZ is bigger. Would you agree with that? Okay. Let's go over here to number 11. What do you think about this one?
No conclusion.
No conclusion. Let's make sure. The shared side is here, isn't it? Okay. We're looking at the included angle. Is what's given to us the included angle? No. So we don't know. Okay? We don't know about DF and FG. Morgan's right. Notice over here, the angle they were talking about is the included angle between the congruent sides. You see that? Over here, where is this angle? It's not in between. The included angle would be here and here, wouldn't it? So we have to be careful. Don't just assume, and you got to check to make sure that we're looking at the hinge theorem first. Okay? Good. So this one is no conclusion. We don't know. All right? How about this next one? Let's look at 12 and 13. Let's just do 12 right now, because I think you want to do one at a time. Can we talk about number 12? Because I think some of us got some strange things happening, okay? And it kind of gave us some food for thought and things that we need to think about. Let's start by setting up our inequality that relates the two angles together. So I think we can all do that without a problem, right? Okay. these two angles, they are the included angles between the two congruent sides, just making sure they are the included angles, so we know we can use them, which is a good thing. If you look at the relationship, 5x minus 10 is across from 18, 45 is across from 12, therefore, 5x minus 10 has to be bigger than 45, right? Because 18 is bigger than 12. And as I walked around, looks like almost all of us got that right. When we go ahead and add 10 and divide by 5, I do get that x is greater than 11. And I agree with that. If you solve the other equation like we did before, so this is always step 1. If we do step 2, like I showed you in the previous problem, and I said it equal or greater than 0, the problem becomes that I get that x, sorry, here we go. I get x is greater than 2. We already know x is greater than 11, right? So this is already the upper bound. We found that already. So we had to think outside the box for a minute, and Marvin did that for us. And actually, when I looked at my paper, I did it too. What could I find to be my lower bound? I found the lower bound. I found x is greater than 11. 11 is the smallest it can be. But what's the biggest it can be? Well, what's another way I can write the angle? I know that 5x minus 10 has to be greater than 0, but it also has to be less than something. What does it have to be less than? Think about a triangle. In a triangle, what's the biggest an angle could be? 180 is, one angle can't be that big, but it has to be less than 180. Would you agree with that? That's going to give us the upper bound. Okay? So, if this doesn't work, which it didn't in this case, we need to go ahead and think about the other bound. So, we're going to go ahead and say 5x minus 10 is less than 180, because we already had our lower bound. We need our upper bound now. Okay? So, when I go ahead and solve this, I add 10 and divide by 5. What is 190 divided by 5? Do a little math over here if we need to. I promise you calculators come eventually. Right there. I got 38. Did you look at that? So I have x is less than 38 and x is greater than 11. So the actual inequality looks like this. Greater than 11 and less than 38. Okay? Let's try 13. 13 will be fractional. You're going to have some decimal answers. Or you can leave them as fractions. You don't have calculators. Just leave them as fractions. It's totally fine. Okay? So try that for me. See what we get. All right, so even though this has crazy fractional answers, I get that. Let's just make sure we can set it up and be okay. First thing I always want you to check, to make sure that it does apply here. Are we using the hinge theorem? So we have 18 and 18, and then we know that because of the shared side, it's obviously congruent. We are talking about the included angles, so we're fine. Here are our included angles. They are in between those sides, so we're good. So we want to look at the sides that are across from those included angles. I know that 9 is bigger than 6. Therefore, 30 is going to be greater than 3x minus 7. Do we agree with that so far? Is that what you guys got? Okay. So now we'll go ahead and we will add 7 and divide by 3. And I do get that x is going to be less than 37 thirds. And we already know, because we have mathematicians in here, that that's about 12 and a third. Right? Great. That is our upper bound. So we're going to go ahead and write our inequality. Because x is less than 37 thirds, that's our 37 thirds, and that says that. We're good. Now we have to find our lower bound, and since we're doing a lower bound, we know it's going to be greater than 0, okay? If we're trying to find an upper bound, we know it's going to be less than 180. Basically, that's kind of like what we need to do. So, first step we did. Second step. What's going to be the inequality I use here, Ingrid? What'd you do? (3x minus 7 is? There you go. Okay. 3x minus 7 is greater than 0. We'll go ahead and add 7, divide by 3. X is greater than 7 thirds. Perfect. Done. Booyah. Happy Friday, y'all. All right? What do you think? anything. Regular geometry doesn't do this, okay? I don't think it's that hard, but it is what it is. The last three problems you'll see there, 14, 15, and 16. Let's just make a greater than, less than. Let's just write a sentence. What do you think? Go ahead and look at those last three here, 14, 15, and 16. Look at our question, look at our picture, and let's decide whether it's greater than or less than. All right, here we go. The measure of angle AEB, is it greater than or less than the measure of angle EBD? EBD, how do you know? Because you got to compare the 21 and the 23. You have to use that Hinge theorem. So I know that these two angles are the included angles. Let's make sure that the two sides are congruent, that make that angle. They are. So we're going to look at the side across from it. Since 23 is bigger than 21, we know that this is true, that angle EBD is bigger, right? Okay. How about AB and BC? Let's look at those. AB and BC. Well, AB is across from 79. BC is across from 59. So since 79 is bigger than 59, AB is bigger. Wouldn't you agree? Good. All right, how about the last one? BC and ED. I hear lots of discussion here. This is like a two-step problem. Because you have to think about EBD being bigger than this guy, don't you? So I know this one's big. I'm going to write big. We don't know its degree measure. We just know it's bigger. Out of the actual angle measure. Okay? But if I know that, well, let's see here. I know that, let's do a transitive property. Maybe that'll work. Okay? I happen to know, let's see, that AB is bigger than BC. I know that BC, right, ED is greater than AB, right? So therefore, ED must be greater than BC, right? Do it that way too. Bigger transitive. Would you do it a different way? No. I was going to say, if you did it a different way, please tell me. I want to know. Okay. So if you want to try to get your homework done, I'm cool with that. Okay, so you just have, if you flip over, it's just the three problems on the top, and then the page before it. That's it. Okay? And all of that stuff is not Hinge theorem stuff. That's just like, can the sides make a triangle? It's a little bit of what we did last class. Okay? So that's your homework. And we're done. So if you try to get it done now,